In this presentation, basically what we are going to see is how we can try to solve a problem by using a predictive model. So I will try to explain step by step the process so you can repeat it by yourselves later on. What is the problem that we are trying to solve? Well, we can just consider that we got this beautiful work as analytical scientist in a huge telecommunication firm in the United States named Megatelco. But as we arrived to the company, somebody told us that there is a huge problem with customer retention in this business. And just to give us some idea, they tell us that 20% of cell phone customers in the Mid-Atlantic region are leaving when their contracts expire. And also the bad news are that it is increasingly difficult to acquire new customers. So we would like to, of course, retain the ones that we have and maybe get more clients. When customers are switching from one company to another, this is called churn. And this is a expensive thing because one company has to spend on incentives to attract a customer while another company is losing revenue when the customer departs. So what we can do in order to try to solve the problem? Well, let's suppose that somebody tells us that it might be possible to get historical data of clients. And we believe that by using that information, we could extract patterns that will allow us to predict when a client may churn. And this can be very good because if we can anticipate which customers may churn, then we could offer them a certain strategy to change their minds and make them to continue with us. So we ask for the data and we get it. So let's start using this data and the general process that we may follow is more or less this one. The first thing is to get familiarized with the data. We will need to answer questions such as how many instances do we have? How many attributes? What do these attributes represent? How many classes are comprised in the data? And how are they represented? Is there any missing data in the database? Is it that we have incorrect information, that we have outliers, etc.? So we, before in this class, had the opportunity to concentrate on this analysis of the data, the cleaning of it, and also the transformation like scaling, the identification of outliers and so on. So we may need to do that in the very first step. Once we are more or less confident that the data we have is reliable, then we will need to construct a model to predict things. And there are many options to do that, different models, different predictors, but also different tools in order to do that. Regardless on how we can create this model, the next step is to evaluate the model. And we will get some kind of grade or qualification of the model. And of course, what we need to do after is to question whether that grade, that qualification that we are getting for the model is good enough or not. And this depends a lot on the application. It is very different maybe trying to identify a client that may leave the company than, for instance, classification related with cancer prediction or something like that, right? But in any case, the thing is that if this grade, this performance of the model is good enough, then we're going to be very happy. We will just apply this model to the problem that we are trying to solve, and that's it. However, if it is not, then a reflection process has to be um, considered. I mean, what happened? Is the data good enough? Maybe it's too noisy. Maybe it's not enough data. Maybe the model that we are trying to use is not the correct one. Maybe the process itself to construct the model wasn't optimized, and so on. So we need to consider that and probably repeat the process after changing some things. And in order to do this, we will need some resources. Weka or any other tool of this kind. Most of the big name companies like IBM, HP, Oracle, Microsoft offer different solutions to perform this kind of operations. So you can consider any of them. Also, we need, of course, the dataset. In this particular case, we are going to use a file that is named churn.arff. And if you remember, ARFF files, which means attribute relation file format, are already in the format that Weka needs to be imported. So we said that in many cases the information will be transformed or written in a text file or a comma separated values file, and then we will need to import it into Weka in order to save it as an ARFF file. But in this case, that is already done. So that is going to be one step that we will just skip. The information is ready for us, and this file is also in Blackboard, so you can download it and you can repeat this process. You can replicate the process and see if you get the same results as I will get in this video. And the last thing is that you may need some time to concentrate. Performing analysis like this one may not be easily done. So you may need the time in order to be able to really think what you are doing and to repeat the experiments or whatever you may need. So if we have all these things, then we can go into the data. And to save some time, I will tell you what are you going to find in the file that we are going to import. It is a dataset that has 20,000 examples, instances, lines, or rows. And each one of these instances has 12 variables, attributes, fields, or columns. So it also means that out of the 12 attributes, one of them is going to be used to represent the class. And that is actually the last variable in each one of the rows. The variable is named leave, and the legal values for that variable are leave and stay. And if we think a little bit on the meaning of this, it basically says that for each one of the lines that is representing one client, we have the resulting action of this client that was either to stay in the company when the contract finished or to leave the company churning. You can see also the information of the rest of the variables in the header of the file, and I have summarized them in this table. So these are the different variables, college or short names for them, income over age, leftover, and so on. And the last one, as I was mentioning before, is the target or the class. Did the customer stay or leave churn? So with that, we are ready to go to Weka for the rest of the exercise. So I will minimize this window and we will go into Weka. So we are already familiar with this first window that Weka offers to us. And we said that when processing data files, the option that we are going to use is this Explorer. So I just click here and then I get this other window. And it is empty, so the first thing I need to do is to open a file with the data. Depending where you store the churn.arff file, you will have to look for it. In my case, I have the data in a folder around here. So it's this one, churn.arff. So I will just choose it, and there we go. It is already loaded into Weka. And we can see before doing something else, some things. First, here, you can see that it is telling us that we have 20,000 instances, as I said before, and that we have 12 attributes. In this other window, I can see the name of the attributes. The first one is college, the second one is income, and so on. And the 12 is the leave or the class. And we can see here in this other window that for that variable, we have two distinct names or elements contained in that variable that are leave and stay. And even more important is that you can see the numbers of each one. So we have 9,852 instances out of the 20,000 that were clients that leave the company, and 10,148 clients that stay. The sum of these two is going to give us the 20,000. But the most important thing here is that if you see, we have almost half of the elements of the data set for each one of the variables or the classes. And that is very good. Very different would be if, let's say, I had 100 of these and 19,000 elements for the state. This graph would be very different. This would be very short and this other very high. And that means that when that happens, we say that we have an imbalance class problem. But happily, it's not the case for the data we have. This is almost perfect, okay? So don't worry about it. So we know a little bit about the distribution of the data in my data set, and I want to classify. If you remember, we also studied a little bit about when building, let's say, a tree for classification, we were interested in finding out which one of the variables was the one that was going to provide the most information in order to classify the data. And that was performed, or one of the ways to perform that was through this concept of information gain. So let's take advantage that we have this example, and let's practice something that we already did before, so we remember. So in order to identify how much information the different attributes provide, we need to go here to select attributes. So if I click there, then I will have to choose the evaluator of the attributes. So I just click here, and then I will choose this option that is InfoGain attribute eval. So this one is going to let me understand how the different attributes are ranked according to the information gain. So I got this alert saying that this ranker has to be used. So I just say, okay, let's do it. And I will leave the rest of the parameters as they are by default. And I will just click here on start. And after a fraction of a second, I got my answers in this window. So the most important part is actually this one. So it is saying, well, this first column is the value of the info gain. This other column is the index of the attribute in the original dataset. So meaning that the first or the most important one is the fifth attribute, the second one is the third, and so on. And this is the name of the attribute. So this means that if I had the restriction of just using one of the attributes in order to classify, I should use the house variable. The second most important attribute to classify is this overage attribute. The third one is going to be this other one, and so on. So depending how many of them I want or I can use, I should be using them in this order. That is what it's saying, this information is saying. So since we are here, let's do something that we haven't done before. If you see here, it says that if I right click, I will get some options. So I will do it. And once I right click here, one of the things that I am interested in is in saving this window that has the results. So I will do it. It will ask for a name. I will put it on my desktop so I can find it easily. And I will use infogain.txt, save it, and you will see that the file is now here in my desktop. Now, I will open it by using any text editor. Even Word would do it, but I will just use my text editor from Mac, because this file has some information that is important for humans but not for the computer, like this description. This is just an explanation, you see? I don't need anything for what I am going to do later, so I will just remove it. Let's see. And also this other portion here is not important for now. So let's go. This is the only thing that I need. I will save it again, and that's it. I will close it, and I will import this modified file into Excel. I want to create a graph. Let's say that I need to present a report to the big boss or something, so I can explain all the process I was doing. Remember that an organization that is data-driven has to have a trace from the data to the decision making, and that is also it is important that in certain points, instead of just adding a lot of formulas or things like that, graph may illustrate that very quickly and without all the hassle of the math. So I will import the file. It is a text file, so I will just click import. I will go to my file, and I will say that the file is delimited, because I will it is separated by spaces or commas or something. So next, blank spaces. You see, now I have columns here. If I unclick this, everything is one thing, but now I have columns. So next, now in order to save some time later, let's take a look at this. So here I have a column that was a blank in my original file, so I don't really need it, so I can just skip it. So it changed there, you see. This one stays as numbers. This third column, we said it was the index of the attribute, but I don't really need the index. So again, I will just skip it, and I will just retain this second column and the last one. And the last one is actually a text, so I can change it. And that's it. I am ready. Once I click fine, I will get, let's say, yeah, the information there. I will do a couple of things in order to prepare a better graph. The first thing that I notice is that usually when I create a graph in Excel, the column that is on the left, and especially when we are talking about 2D graphs, is going to be the values in the x-axis. And the column that is on the right is the one that contains the y-axis values. And here we have this inverted. This is the y and this is the x, but they are in different order. So what I will do is I will cut this from here and I will insert it there. So insert, there we go. You see? Now it is in the correct order. I'm sorry. And we're just trying to change the size. All right. And even more, I will insert a row here to add the headers for the columns. So this, we said, is like the attribute name, and this is the info gain. So that's it. And once we do that, we can just select the data, insert a graph, and I will use a column in order to do it. And there we go. We have a really nice graph that is showing graphically this idea of the info gain. So you can see here the variable house, the variable overage, and so on. And the bigger they are, the more information they are giving for the classification. So these two are quite good, actually these three, and the rest are less. And these ones, like reported satisfaction, college, considering change of plan, and so on, they are not that important. So if I don't want to create a huge tree, I could skip some of them and just retain the rest. Of course, when we are creating the model, we can experiment with different amounts of variables, and that may change the performance of the classifier, but that change could be actually negligible depending on how much it changes. So this was just to illustrate how we can save information out of Weka and import it into other different tools like Excel in order to prepare graphs. Of course, having the table in the file or here, I could have used R to create this graph, or even to make some analysis or whatever. So you can choose whatever you want, right? So let's minimize again Excel and go back to my original window in Weka. Now, what we wanted to do originally was to classify the information. So let's go to that option in Weka, classify. And of course, I will need to choose the classifier. And you can see that there are many options. The one that I want to use now, because it's very intuitive later to analyze, is one kind of tree. So I will click on this folder, and there are different ways of constructing trees, and we will use this, which is the J48, which is a very well-known algorithm to create classification trees. So I will leave the rest of the parameters as they are for now, and I will just start the classification. I will change something here, this option, so I can save some time, and this basically means that the algorithm is going to take 66% of the data of the 20,000 instances are going to be used to train the classifier, and the rest, the 34%, is going to be used to test the classifier once that it has been generated. So if I press start, the bird is moving, so it means that the computer is working, and it finished. It was quite fast, and so let's see what it generated. In this case, we didn't ask the computer to skip any of the attributes, so it is using all of them, and the tree is actually going to be very big because it's all the combinations of those variables. Anyway, so here it is summarizing the information: 20,000 instances, 12 attributes, which are these ones. The test mode is split, so 66% for train, the remainder for test. And you see, we said by using this InfoGain computation that the most important variable to perform the computation was house. And here we can see it. It's the first one that is used. This is the root of the tree. And the second variable was the over age, and here we have it. And the third one is leftover, and so on. So here we have, in this weird representation, the tree that will generate this classifier. And again, in this part of the window, we can see that we can click with the right button, and and we can get some things like the option to visualize the tree. So if I click here, I will get the tree, but of course it is very, very big, and if I right click, I can make it to auto scale, but I lose it. Fit to screen, there we go. And let's see, there is a way in which I can change this to be a little bit smaller. And I can drag it. Maybe it's too small. Let me go back and change it a little bit bigger. There we go. So let's see. Hopefully this is too big. The root is going to be here. So this is the root, and what it is saying is that if the value for house is smaller than or equal to this value, I should go to this branch, otherwise I should go to the other one. And that means that, let me go back to my presentation. This on the screen is like a short version of the tree that we got. So we had this house, we had the partition of the original set or the variables depending on the value that house has, and then operation income in the second level, and so on. So if a client has a value bigger than or equal to this number for the house and an overage bigger than 97, the probability of churn is 0.79. So for those cases, I can very quickly identify that they are very likely going to go from my company, so I can do something for them. And the same thing I can do for the rest. So the tree will allow us to predict clients that may churn, clients that may stay, and when that happens. Now, even more, we have results coming out from the classifier. The thing is, can we explain the results? And here, let me go back to Weka. There are different things, and one that I may want to spend some time is these two lines. Here, basically, what we are getting is that by using this tree, we are able to get a correct classification on the test instances of 68% of the time. 68 cases out of 100 were correctly classified, and 31 were mistakes, almost 32 actually. Is that good enough? Well, it depends. It depends on, as I was saying before, on the problem. I believe that almost 70% of correct classification is quite good for this kind of problem. Can we do better? I don't know. How to know? Well, I could change parameters on the classifier. I could change the classifier, not a tree, but something else. And that is actually something that a data scientist may have to do. But for you, if the results that the people is presenting to you are something like this, you can understand what is the meaning and how they were obtained. And we have more results. Here we have the true positives, the false positives, we have the precision, the recall, some metrics, and so you can take a look at this information either on Weka's documentation or on the internet. You can find the definition of these things and why they are important to be reported. And also we got this confusion matrix that we already studied before. Here we can see how many leaves were classified as leaves and how many stays were classified as stays. And the rest, this here, are mistakes. All right? So, and those numbers are used to compute these rates. So you can do it. Anyways, so far what we have done is then to use Weka in order to generate this tree or the one there, and so we are basically ready to do another thing by ourselves. I hope everything was clear in this presentation. See you in the next video.